So I just want to know your overall view, how it has helped you as an engineer and your clients.
It's a wonderful code. It's like a marvel of the engineering. Service industries, inspection guys, the maintenance person, the process person, everybody is happy. What is that has gone wrong? What is its definition? What are the critical factors which are affecting that? That's one.
Plants or equipments or the structures, they are designed for a particular positive life. So normally pressure vessels designed for 20 years life, but we have fertilizer plants running for 40 years. Cripco.
Like you, sir, you are also fit and fine with 55 plus years of experience. I recommend to study this program and find out defects beyond acceptance. Welcome to the podcast of TCR Advanced Engineering Private Limited on Fitness for Service, FFS, API 579, ASME FFS 1 for process industries. We call this a living with the defects. This is a standard which is very popular amongst the people, those who are in the industries, and especially they want to validate their equipment component with the defect, and also a guideline which has been provided to run them safely without the problems. The idea of fitness for service has come from the fact that industry was working before 2000 on the guidelines of the construction code. All the rejection and acceptance were happening based on these standards. Now, whenever the equipments they are in the operation, when the defects are growing or the same defects which were there during construction was also giving them problems for repair, and hence industry needed a specification where API came to the rescue and rolled the first standard for fitness for services, API 579 in the year 2000. After that, ASME joins the hands with the API and started API 579 ASME FFS 1 in 2007, and they have given another two revision in 2016 and 2021. The world also had the another specification called BS 7910, which is more on the acceptance of the flaw and a fracture mechanics based specification. And I'm extremely pleased to say that we have two experienced voices from the industries, Mr. N.K. Roy and Mr. Ketan Upadhyay, who cumulating having more than 100 years of experience. And we will going to go through this podcast, and I welcome you gentlemen for this podcast. And I have the pleasure of working very closely with both of you. So we will take this journey, and my first question to Ketan Upadhyay. Ketan, you have done a lot of fitness for service assessments for the industries. So I just want to know your overall view about this specification, how it has helped you as an engineer and your clients.
It's a wonderful code. It's like a marvel of the engineering, rather. And these people who are in the industry are suffering of inspection findings. I found this defect and now I'm in trouble. What to do? Repair? Crack? Okay, grind it, repair it, post-bed retreatment. Those sort of problems are very well attended by this code, and it gives the solution what to do next. So it's like a win-win situation for all service industries, inspection guys, the maintenance person, the process person, everybody is happy.
That's the beauty of it, and very well explained, Ketan. Would like to ask respected Roy sir. Sir, in your career, you must have done a lot of FFS jobs. So, can you second what Ketan has talked about, the delight which is bringing, especially the stakeholders? It's very important because of them, everybody gets the job. So, how do it helps industry for improving the safety and continuous operation?
He mentioned it well that things starts with the design of a equipment, a piping system of a process industry. So design is the first stage, then it goes to manufacturing. And in manufacturing, he mentioned about number of steps. those are important for maintaining integrity of these equipments. And then he mentioned there are inspections being done by the industries. They get damages, defects, how to evaluate, how to assure that this defect will be safe for a long period or it is going to be dangerous within certain period. I remember a case, I think it's a 40 years old case. And one of our stainless steel vessel manufactured by Anup Engineering in Ahmedabad was to be supplied to a fertilizer plant near Kakinada, Odisha. And during transportation, it was all okay. But when they were unloading this vessel at the site, it got dented.
Oh.
And the stainless steel vessel, urea plant, and it has got a dent which is beyond acceptance of the code. ASME code, fabrication code allows you deviation into this. That was posed to us. And luckily, since I was in failure analysis and such plant problem investigation, so it was referred to me, and I had to scan a lot of literature relevant to this.
At
because
this time, the standard was not there. So this was a greater challenge.
That's right. So we came out. We searched. There were a few cases reported by ASME code. It was published in the international journals or conference proceedings. So I searched out 3-4 of them, very relevant to that. And then based on to that, I did the analysis. And I reported that this vessel, don't repair, that will damage it more. As dented, let it be erected. And that was on the basis of certain calculation. So that was the first one I did. And when I saw your FFS, Fitness for Service, and there is a chapter on dent and bulge and those things, I was really delighted. Something which I did 40 years ago with a lot of problem had been opted by.
Wonderful. I can understand your feeling and the happiness behind the judgment, which was not supported by the code all the time. So that's absolutely amazing. Now people say that, Ketan, that fitness for service is a multidisciplinary activity. Can you elaborate on this aspect a little bit?
Yeah, sure. It's like, number one is that we need to understand what damage has undergone for any equipment or piping. That starts with identifying the damage mechanism, number one. And that is entire chapter over there. And API 571 is referred into this API 579 that you have to refer. What is that has gone wrong? What is its definition? What are the critical factors which are affecting that? That's one. So first thing that the first role comes is of a metallurgist and a chemical engineer, both together. Because process and material both
very well said, Ketan. Because I always advocate this point that it's a process people who needs to understand damage mechanisms.
That's right. The second point would be the integrity aspect with respect to mechanical integrity. So mechanical engineers, definitely they have to evaluate through various methodologies. There is part 2 in API 579 which is describing all those equations, how to use those equations, how to derive the stress levels, how to derive the minimum required thicknesses. So these points are to be covered with those experts who are in designing day in, day out, related work. They are mechanical engineers. So it's a multidisciplinary act, and often it it related with some instrumentation. So electronic persons, the instrumentation engineers, you are all part of this.
And also entity expert and also fabrication expert. It's basically a multidisciplinary activity. Absolutely. Roy sir, I will be very happy if you enlighten our listeners that what is the role of finite element analysis in fitness for service, and how important a finite element analysis is, especially when you are going for level 3 assessment.
Yeah. Actually, the ASME code gives you equations and methods how to analyze for stresses in different loading conditions. They give it. And the best part is that lately, the number of design software had got developed. We know PVLite or Compress, CodeCalc, they are the softwares for preservation. Similarly, for piping, there may be Caesar or Autopipe. These are the software which has used the guidelines of the code, design code, in a computerization format where you can do the job faster. If you go through those basic equations, and try to do manual analysis, it will take months to analyze and come out with a solution. But he knows that if once you model a pressure vessel with certain defect and all those, within a few hours you are having all the report and stress distribution. But there is a limitation in those. Now, softwares are getting developed where FEA is now built in. I got just a month earlier a notification from Codeware that they have developed a software which does the old design calculation. Side by side, it gives you FEA stress distribution at a certain critical location.
Because it's a AI type, sir.
That's right. Yes. So you are getting that thing through our software now faster. Earlier, what we used to do, manual calculation, software, as I mentioned, and then wherever there are certain doubts, there are discontinuity, there are geometrical complexities, we used to go to FEA. And that used to give us the idea how the stress in that geometrical complexities is changing. And if your defect is at a point where the stress is very high, automatically that will be more dangerous. So that is where FEA helped us.
But sir, how do you consider, because I feel that most of the people, they consider fitness for service is by doing only FEA. I have my reservations, as a person in the field. I understand many times when people are trying to do FEA based on FFS based on only FEA, then they are missing on certain degradations of the materials which has occurred. So what is your view on this? Because we have seen the practical aspect of material degradation and property degradation is not being taken into consideration. So how do you rate, how do you consider the FEA is one of the tool, or FEA is the main in fitness for service?
FEA is a tool, but it requires certain experts who has inbuilt expertise in pressure vessel or piping or structural design. Unless he knows that, he cannot model the thing on a FEA analysis software.
And the material degradations which has occurred over the time.
Material properties, yes.
Properties. Suppose you take the design consideration, it may or may not be existing. So how do we? So this is an important aspect. Ketan, can you elaborate this aspect, because I have seen working on these projects, especially, and how do you validate such condition where the material property also has affected, and you have come out with some solution?
Starting with the first part is that I am also a postgraduate in diploma computer science, so I understand programming. Garbage in is garbage out. So if you don't understand what you are feeding in, you are getting obviously wrong results. And not all the FEA vendors, or those who are so-called experts, are doing it correctly. Second thing is about the part 7, if you refer, of API 579. They very categorically mention what is the HIC damage, hydrogen induced cracking, blistering. What is the extent of the material that has undergone damage with respect to hydrogen ingress? If we don't know what is the fracture toughness as on day of evaluation, when we are doing it, and we are considering the original fracture toughness, it will be a wrong result.
Okay.
It will be a disaster. So FEA just asks for input. What is Poisson's ratio? What is modulus of elasticity, and all these things. But ultimately, it requires proper input.
Yes.
Absolutely, absolutely. And refineries especially, they are utilizing, and fertilizer industries, they are utilizing a lot of hydrogen related equipments, and there are direct and indirect charging of the hydrogen in the equipment occurs. So Ketan, you brought a very valid important point, and most of the time the my experience is that the industry requires fitness for service in such critical services. I remember one case when we have allowed the reactor with the crack in the hydrogen service itself, and industry got benefited immensely. Maybe 100 plus crores were saved because of that FFS study. So FFS study has a great potential, and I have people, those who advocate this, especially in the requirement. And Roy Saab, suppose if we look for the plant extension, plant life extension is the buzzword which needs in our country especially, and globally also, as the resources of the new plants are very costly. And also, making a new plant and infrastructure, rather than, revamping it into 5 to 10% or 15% of equipment, can increase the life to 25 to 30 years. How does fitness for service can, help industries for the plant run extension time?
Yeah, automatically, we know that plants or equipments or the structures, they are designed for a particular positive life.
Yes.
So normally pressure vessels designed for 20 years life, but we have fertilizer plants running for 40 years. Kripko,
like you, sir, you are also fit and fine with 55 plus years of experience.
So that applies to industries also.
Yeah.
So it is designed for a limited life, but unless you are able to monitor it, like in-service inspection, regular inspection, and then evaluating what is the damage, how dangerous it is it really still safe to operate for 20 more years? Okay, you operate those equipment for 20, and that is how these fertilizer plants are petrochemical refinery. Our Baroda refinery itself, I think it is 50 years old plant. Number of equipment may have been.
Sir, in Assam, the Digboy refinery is the oldest. They have crossed century plus.
Century plus. So this is all due to such integrated inspection, timely inspection, identifying damages, analyzing it more thoroughly, and then assuring that things will be safe for certain more period. That's how you increase the life. That's you gain in economy of the country, rather than retiring.
And safety also.
Safety
also,
safety
because you know exactly when to retire and how to retire. Rather than taking a decision because failures are occurring, or change the equipment. That's an age-old style. Yeah, well, that's wonderful. See, we all have talked about a lot of positive aspect of fitness for service. Ketan, can you give us the limitation of fitness for service? Because there is a scope in improvement in every field. I'm sure there must be some limitation of the fitness for service also. So can you throw some light on that?
There are certain points which are missing with respect to material degradation conditions. For example, if we talk about part 10, for example, creep evaluation. Okay, so they have mentioned this omega method. Omega method has a list of all these material properties, A1, 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 A2, A3, and even B2, B3 parameters. But they are silent on delta CD, delta SR values, which are the creep ductility parameter and the rupture parameter.
Okay.
They say it's like generic plus 0.3 to minus 0.3 or plus 0.5 to minus 0.5.
So they have left to your experience.
To your experience and certain amount you have to do some
which means the limitation of the standard is that it is to be dealt by experienced people. That is what you're trying to convey in short.
Right, that's right.
That's right. That's
Exactly.
right. So, but I was just thinking, Ketan, about, and sir, you also can help. There are two damage mechanisms which are not considered in fitness for service. When it comes, fitness for service doesn't give the permission to run. One is high temperature hydrogen attack, that is HTHA, and another one is stress corrosion cracking. So why it is so? I would like to know from both of you. First from Ketan and first from you, sir.
So basically, if we talk about SCC, stress corrosion cracking, any kind of SCC doesn't have any known rate of propagation. When we don't know what rate it will propagate, it is very difficult to identify whether it will be safe with this crack or not. And there is no definition for that. What they say is that you may do certain, simulation in similar environment and establish, or you go with your past experience.
So that's a gray area.
that's a
So
limitation.
that's a
That's a
limitation.
limitation. Second limitation about HTHA is high temperature hydrogen attack is something which is related to degradation of the material itself, and it can be associated with cracking, it may not be associated with cracking, and very early stages it is very difficult to identify or detect. That's the first limitation itself. And what API 579 states is that you refer to API 941, where there are incubation times which are mentioned, that we can go ahead with that methodology for suspecting HTHA with respect to temperature and hydrogen partial pressure. But
rest all the damage mechanisms, you are very confident.
yes,
That's great, sir. What is your views on this too? Because it's important that we all should know the limitation of the specification.
Initially, you touched about stress corrosion cracking
yeah.
sort of thing. There are methods, just like fracture toughness testing. The K1C or fracture intensity factor.
SSRT test is done.
SSRT or
stress
K1C
tests.
testing, they call it fracture toughness parameter testing.
Okay.
That includes the material property. It's a material property. And it correlates defect with stress. That's the beauty. For a particular material, it has to be tested. Those data has to be consolidated.
Yeah.
And FFS has done very good effort. I think they had consolidated a lot of those material data which are commonly used in.
But sir, I have one thing that's covered more under BS 7910 rather than API 579.
You can integrate.
So, but basically
Nobody
what he did the FFS when FFS was not there.
Yeah, correct.
So,
I did even crack investigation of a methanol converter of some company close by.
Yeah.
And it was under fabrication at a very prestigious fabricator in those time. Again, 30-40 years old case. During that multi-layered vessel assembly and welding, inspection, radiography and whatever ultrasonic testing of the weld. And the vessel thickness was around 112 millimeter, if I remember it still. And at the midsection of that welding, that 120, other is multi-layered shell. But you have to join multi-layered shell together and it has to be thoroughly welded, full
absolutely
thickness. And in that, during inspection, ultrasonic was the major one which was used. They found a crack-like planar defect in that weld. Now, how to repair? ASME code says repair it. So there was a problem. Okay, that one trial was made to repair and take out that defect. It was done and re-welded. Again, same thing. Again, same planar defect, mid-thickness. I had attended one international conference and I was doing a specialist study on fracture. So it was referred to me, can you come out with some solution, whether to accept this or not?
Yes.
So I remember fracture toughness. I got the thing tested in Welding Institute, UK.
Okay.
Belfast. Dr. Wells was the head of that. I knew him during that international conference. So he accepted this thing. We will test it for you, give you the cables. And then I determined the...
it's safe.
It's safe. And I made the recommendation. It's safe. Go ahead without repairing now.
Excellent.
If you repair it.
Excellent. So this is what I want to tell the industries very categorically, that do not afraid with what you observe. There is always a way. When you do fitness for service, sometimes you find that the equipment is not acceptable. Consider this as the knowledge, because running the equipment in a wrong direction will give you disaster. But unnecessary accepting or repairing the situation will introduce more stresses in the component. So fitness for service, like both of them, is one of my favorite specification standard, and I always have enjoyed working on the specification for the industries. And I would like to extend my very deep gratitude and thanks to both of you for providing the wonderful knowledge which is helpful to the industry. And I also would like to tell that TCR Evolve has come out with the specific program on fitness for services, and I would like to show that brochure. So this is the brochure. It is say integrity despite defects, and this program is covering the fundamentals of the fitness for services. This is I recommend to operation engineers, maintenance engineers, design engineers, inspection engineers, welding engineers to study this program and find out the defects beyond acceptance and how it will reflect. That does not mean that we fabricate our components with defects, but if they have come in the operation or they have come, this program will be immensely benefit to them. Once again, if you guys like this program, do like the subscribe button and share with your friends and colleagues. Thank you.
Thank you.
Thank you.